Welcome to Study Loop.
30.80, this is referring to the previous couple of questions. Basically, in the previous question, you would have shown that if you have an atom with 4 energy levels here, that if you de-excite from the 4th to the 3rd level, and then go from the 3rd to the 1st level, that this would be that these two photons, the sum of their frequencies would be the same as going directly to the ground state. And this is because the energy of a photon is Planck's constant times the frequency. And so the fact that you're going the same total distance in either case, which we can say is E41 equals E43 plus E31, implies that F41 equals the sum of these frequencies, F43 plus F31. So that's all well and good, and this is a little review of the previous problem. But now we want to know if there's a relationship among the lambdas. So for all waves, including light, the speed, which instead of v we use a c for light, is equal to the wavelength times the frequency. And so if we divide both sides of this by the wavelength, we get that the frequency is the speed of light divided by the wavelength. And so we can substitute this in for our frequency in this expression. So c over the wavelength from the 4-1 transition has to be equal to c over the wavelength from the 4-3 transition plus c over the wavelength from the 3-1 transition. Now we have a factor of c in all of these, so we can divide our equation by c, and we find that 1 over lambda 4-1 equals 1 over lambda 4-3 plus 1 over lambda 3-1. So in both cases, we got this from the fact that these energies have to add up to be the same, because there's the same distance and energy that you're moving in both cases. And that gives us both that the frequencies add of all these photons, and the inverses of the wavelengths also add. So the wavelengths don't add, but their inverses do.